Hello and welcome to my Physics 2212 Lab 4 of magnetic fields. The purpose of this lab is to exemplify the physics behind magnetic fields and magnetic dipoles, and how these can affect magnetometers and change the direction of compasses. So this is like a graphic of how dipole magnetic fields uh, work, and this is another graph of the dipole magnetic moment. The principles in action. The dipole magnetic fields describe how a magnetic dipole creates a field in like a butterfly shape, which is the same shape as an electric dipole. The dipole magnetic moment, that the magic rocks have a magnetic north and a magnetic south, and that determines the direction of the magnetic field. So this is the experiment. We used a magnetometer app in the phone to measure the magnetic field. We moved the phone vertically or horizontally until we got to our target magnetic field. The distance moved was measured by a ruler. We recorded the data in a spreadsheet to analyze later. Here's a quick video of how we did it. Here is the phone with the app on top of the ruler, and as you can see, we moved it until we reach our target magnetic field, and we recorded the data. The system and the surroundings. The system was the phone magnetometer, and the surroundings were the magnetic rock and earth. So this is how it worked. So first we did an experiment on axis, and we got this line for log of magnetic field versus log of distance. And the magnetic off axis, we got these results for each trial. And here we moved phone on axis until the magnetic field was 100 micro teslas. Then we recorded this position and moved this phone the same position but up. So we recorded that the net magnetic field was the magnetic field of the magnet plus the magnetic field of Earth. So now the description of the computational model. The magnetic dipole moment mu was 11.42. The distance was 0.2 meters, and arrows on and off axis were made to visualize the magnetic field, and the magnetic field at 45 degrees was recorded to be 38.5 micro teslas by this model, and we used this formula for the magnetic field calculation. Put the magnetic moment of the magnetic dipole. Here we have a function to calculate the magnetic field at any given point. Here we have all the observation locations for all the arrows I'm going to show, and that's it. Here is the graph of all the arrows at different locations, and that in the middle is the magnetic dipole, and this is the off-axis observation location, the same distance in the x and in the y direction. Put the So now the comparison. The similarities is that the direction of the magnetic field at 45 degrees had the same direction in the experiment and in the computational model. And the difference were that the experiment and the computational model predicted similar values for the magnetic field, but they were not the same. So possible sources of error could be that the magnetic field of Earth could have affected the measurements, also that the magnetometers were not ideal as they were phone apps, and also human error was possible in every measurement. The assumptions for this experiment was that the phone is perfectly aligned with Earth's north. The magnetometer on the phone is on top of the ruler, and that no interference from other electronic devices were present. So what if the phone was not oriented to compensate for Earth's magnetic field? The Earth's magnetic field would affect the measurements in all directions, but if we measure this field, we could subtract it from the net field and get the same results. And what if you stuck two magnets together and rerun the experiment? This would create a bigger magnet that is twice as strong with twice the magnetic dipole. This would double all of our measurements. Here's a link to my simulation, and thank you.